Welcome to this explainer from Forge College. I'm absolutely thrilled you're here. Today, we're diving into advanced Solana-cli command patterns. We're going to transition your Solana developer skills from handling single manual transactions to engineering reliable automated blueprints. Now, if you've been following our Mastering Solana CLI course, you already know how to submit and monitor a single transaction from our last lesson. But let's be real here. Doing that 100 times manually is a fantastic way to completely lose your mind, and probably your LAN ports too. So that's exactly what we're drafting today, a safe, automated read-only machine.
Okay, let's quickly review our blueprint for today. We've got 6 key stages. 1, from transactions to pipelines. 2, mastering JSON and JQ. 3, safe cluster management. 4, snapshot, normalize, and compare. 5, building your snapshot script. And finally, 6, automating your next steps.
All right, let's jump right into section 1, from transactions to pipelines.
So in our previous lesson on submitting and monitoring transactions, you laid down the foundation. You learned how to create, send, observe, and log. Now we're shifting gears. We're going to take those exact same building blocks, those same raw CLI primitives, and use them to compose automated command pipelines. Think of it like taking individual Lego bricks that you've been playing with on the floor and finally assembling them into a fully automated, well-oiled factory. But to actually do that, we have to entirely change how we look at our terminal. Let's be honest, trying to manually parse human-readable, colored CLI text by hand, it's literally like trying to read the Matrix, or I don't know, reading tea leaves. It's incredibly brittle and it's highly prone to human error. I mean, if a validator's state changes just slightly or an epoch rolls over, your human eyes might just completely miss the regression. So we need to engineer a much more reliable method for our scripts to understand what's happening on chain.
Which brings us nicely to section 2. Mastering JSON and JQ. Just compare the chaotic, messy, human-readable output you're used to with clean, perfectly structured, predictable JSON. This contrast is exactly why we absolutely must start using the -- output JSON flag on our commands. When you output to JSON, you stop guessing. Period. You get this completely machine-friendly format that your automated scripts can parse without ever worrying about, say, terminal colors or text formatting updates randomly breaking your code down the line. But getting the data into JSON is really only half the battle, right? To actually manipulate that JSON, we're introducing a tool called JQ. Think of JQ as the precision gears and levers of your automated machine. It basically takes that huge block of structured text and neatly filters it down to extract the exact, precise, machine-readable fields you need.
So, the crucial takeaway here is that by combining these flags, you achieve engineering perfection. You run Solana balance, you ask for the JSON output, and then you just pipe it directly into JQ to ask specifically for the LAN port's value. And what pops out? A clean, single numeric count. Your downstream automation tools can easily read that and use it for logic, alerts, or monitoring. It's elegant, it's simple, and it's completely robust.
Let's keep moving. Section 3, safe cluster management. We handle cluster management safely by using configuration profiles. A config profile basically acts as your anchor. It's a named set of settings for DevNet, testnet, or mainnet. Because look, leaving your RPC endpoint to whatever happens to be the default configuration on your machine, well, it's a bit like letting Jesus take the wheel when you're driving a bulldozer. You really do not want to accidentally run a script against mainnet when you genuinely thought you were safely on DevNet.
To maintain absolute control and safety over this, you must always explicitly pin your cluster with the -- URL flag right inside your scripts. Don't rely on local, hidden configuration files when you're writing automation. By explicitly stating the URL right there in the command pipeline, you guarantee that your read-only machine is always inspecting the exact environment you intended to. No surprises.
Moving on to the assembly line itself. Section 4, snapshot, normalize, and compare.
This 4-step workflow right here is your primary engineering blueprint for managing resources safely. First, discovery, finding the candidate accounts. Second, snapshot, capturing the data. Third, normalize, stripping away all the noise. And fourth, compare, checking for the actual differences. Using this specific flow means you will never again be manually hunting for subtle regressions or random errors in your infrastructure. It does the heavy lifting for you. Now, this snapshot phase is particularly vital in this blueprint. It freezes the state of an account or a node in a precise moment in time, creating a timestamped JSON file. This basically becomes an auditable artifact. If something goes wrong on chain, you don't just have a vague error message. You have a frozen, exact historical record of what the state looked like right before the issue even occurred.
This schematic lays out the whole process perfectly. For discovery, you might use Solana validators to find your target. For the snapshot, you use Solana account to grab the raw data. To normalize, you pass it through JQ with custom filters to isolate just the fields you actually care about. And finally, for compare, you use standard diff tools on your local machine to see exactly what changed between your old JSON file and your new one. It's a beautifully simple, highly effective read-only loop. All right, let's take this off the drafting board. Section 5. Building your snapshot script.
You might be wondering right now, especially if you're somewhat of a beginner to automation, how on earth do we automate this without the terrifying risk of accidentally spending real lamports or altering the state? It's a totally valid fear. And as engineers, we solve it through strict, uncompromising constraints. We solve it by following these 4 golden rules. 1. Always use explicit --URL flags. 2. Build the script using only read-only commands like balance or account. Never use write commands here. 3. Always save outputs to timestamped files so your scripts are idempotent. And 4. Route raw errors to a separate .err file so you don't accidentally corrupt your clean JSON. These strict constraints are exactly what keep your machine safe. Now here is your final ultimate safeguard. Before your script passes that snapshot file downstream to an alert system or a database, it must validate it. You just write a tiny check to ensure the file isn't empty and that JQ can actually parse it without throwing syntax errors. This completely prevents silent failures where, say, an RPC network timeout accidentally gets logged as an empty balance.
Okay, almost there. Section 6. Automating your next steps.
Let's quickly recap our entire blueprint for today. Always rely on machine-friendly JSON over messy text. Always pin your endpoints so you don't cross environments by mistake. Utilize our 4-step workflow for rock-solid monitoring. And prioritize safe, read-only validation. Seriously, if you do these 4 things, your automation will be practically bulletproof.
And remember, the exact read-only primitives that we just built today are the tools you're going to reuse constantly. In fact, in our next lesson on creating and signing transactions, you're going to use these exact pipeline strategies to prepare signing contexts and run pre-flight assertions. That way, you guarantee your transactions will succeed before you ever even hit send.
I really want to leave you with this core engineering principle. When you're building out your automated pipelines, strictly validate everything. Build them so that they fail loudly and clearly when anything unexpected happens, like an RPC response suddenly changing its format. A loud failure is an engineer's absolute best friend. A silent failure? That is a nightmare. And that wraps up our blueprint for advanced CLI patterns. Before you go, ask yourself this. If your validator state corrupted right this second, how long would it take your current setup to actually notice? Well, you now have the schematics to catch it instantly. Please make sure to visit forge.college to dive deeper into the subject, explore our other amazing Web3 related topics, and of course, keep building the future. Thank you so much for joining me for this explainer, and I'll see you in the next one.